today's tutorial, we're going to be looking at something very important. We'll be talking about matrices or matrices. How do you pronounce that? Matrices, right? Matrices. Okay. So we're talking about matrices, right? So what's the matrix? Basically, matrix is a rectangular array of numbers, right? A matrix is a rectangular array of numbers. So that's basically what matrix? Matrix is a rectangular array of numbers in rows and columns, right? In rows and columns, right? So it also includes within a bracket. Matrix is a rectangular array of numbers in rows and columns enclosed within a bracket. Enclosed. Let's put that there. Enclosed within a bracket. Enclosed within a bracket. Okay. So this could be a bracket, right? And then I have A, B, C, D, E, F. Okay. Now this is row 1. This is row 2. This is column 1. This is column 2. This is column 3. Okay. So that's basically what a matrix is. So we could name a matrix, right? Okay. So if I call the row first, then I'll call the column. How many rows are here? We have about 2 rows and 3 columns. So it becomes 2 by 3 matrix. So the matrix is a 2 by 3 matrix. This is a 2 by 3 matrix because it has 2 rows and 3 columns. So this is a 2 by 3 matrix. A 2 by 3 matrix. 2 by 3 matrix. So now you can write it this way, you can also write it 2 by 3. Okay. Just the same way in mathematics. With the dimensions of a building is 3 by 4, right? It means the length and the breadth, right? It tells you about the length and the breadth of that building, isn't it? Okay, of that particular area. Okay, so that's basically what it is. Of that area, I think that would be the best grammar for that. Okay. So A, B, C, D, E, F are called what? Elements in the matrix. A, B, C, D, F. A, B, C, D, E, F are the elements. This guy. They are called what? Elements in the matrix. So those are what's called elements. So what do? What do we usually do with the matrix? So we said the matrix actually tells us what it's a rectangular array of what? Numbers in rows and what? Columns enclosed within a bracket. Okay. So we could have types of matrix. We have column matrix. We have a square matrix. We have a column matrix. We have square matrix and the rest. So a column matrix is a matrix that is just like this. 2, 3, 4. But it's a column matrix, right? Because it's just made up of one whole column, right? This is a column matrix. Okay. So we could also have what is called a square matrix. A square matrix makes you see the same row, the same amount of rows and columns. Let's say you have 2, 3, 4, 5. So this is a square matrix because it has 2 rows and 2 columns. 2 rows and 2 columns. So that's a square matrix. Okay. So in naming the position, getting the positions of a matrix, right? You can get the positions on a matrix. So in getting the position, the row is taken first, then the column. The row is taken first, then the column. Let's say I want to detect or show the position of this matrix. What do I do? So this is basically A11, right? And that is what? A12. So this is row 1, column 1. This is row 1, column 2, right? So we have A21, that's row 2, column 1. And then A22, that is row 2, column 2. Row 2, column 2. So remember, I told you that the rows are by this other side. So this guy is the first row, the second row, and this is the first column, second column, and third column. So you can also detect the position of this guy, right? The position of this one will be what? A11, right? The position of this one will be what? A12. This one will be what? A13. This one will be A21, A22, and A23. That's basically how to detect the position on a matrix. So to detect the position of a matrix, just what we've done is what should be done, right? Okay. So there's other things we want to talk about that relates to what matrix. We want to calculate this matrix. A equals to something like this. Minus 2, 3, 5, 6, 4, 1, 7, 2. Something like this. And then what do we want to do with this? Basically, we have to find the position. So find A21, B, A23, A32, C, A23. Okay. So let's find the positions. Let's see, yeah. A21 should be equal to what? Remember, row first before what? Column. So row 2. In row 2, we have 5, 6, and 4. In row 2. We have 5, 6, and 4 in row 2. Then, that means row 2, column 1. In row 2, column 1, we have minus 2, 5, and 1. In row 2, we have 5, 6, and 4. And then in column 1, we have minus 2, 5, and 1. Okay, so this is row 2. This is column 1. Okay, so basically now, at that position, which position will the two of them meet? This is this, and this is this. So basically, it should be this guy. So we have what? 5. We have 5. So the next one is A32. A32. What will A32 be? A32 means row 3. Row 3 is row 3. Column 2 is column 2. So which guy will that be? So it will be able to be this guy, right? Row 2, column 3 is this guy. So we have 7. So C, we have A23, row 2, column 3 is column 3, right? That's column 3. So row 2 is this guy. Column 3 is this guy. So we have 4 there. Okay. So that's basically what that should be. So that's what that should be. So we have the equality of a matrix. Equality of a matrix shows that they have both the same rows and the same weight. Column. So if the corresponding elements are equal, then they are equal. If the elements are equal, then they are called an equal matrix. How is the elements equal? That means one is in matrix A, is the same thing as one is in matrix B. So we say that that one is an equal matrix. So that's it. So let's look at another one. Let's look at the main thing, addition. Addition of matrix. Addition. That's very important for us. Addition and subtraction. Let's do the both together. of matrix. So addition and subtraction of matrix is very easy, right? The two matrices must have the same number of rows and columns, right? It must have the same number of rows and columns, the two of them, if you want to add them. If I want to put two matrices together, they must have equal number of rows and columns. If they don't, then it becomes a big problem to add them. Okay. Let's look at an example. So if I'm to add two matrices A, let's say matrix A is this A11. Remember, this is the matrix, right? And this is the elements. The elements are written in small letters. A11, A12, right? Hope you are correct. Hope you are correct. Yeah, you are correct. A13, A21, A22, A23. We have A31, A32, and A33. So we have matrix B. So we have B11, B12, B13, and then B21, B22, and B23. Then B31, B32, and B33. Okay, so what do we do here now? I want to add them. So A plus B will be A11 plus B11. Then we have A12 plus B12. Then we have A13 plus B13. Okay, so we have A21 plus B21, A22 plus B22, A23 plus B23. So finally A31 plus B31, A32 plus B32, A33 plus B33. Okay, so that's basically what we do. Let's look at this example. So example we have. So the same thing happens for subtraction, right? So A minus B will be the same thing. A11 minus B11. A12 minus B12. A13 minus B13. So we have A21 minus B21. A22 minus B22. A23 minus B23. A31 minus B31. A32 minus B32. A33 minus B33. So that's basically what it is. So let's look at two examples. One from addition, the other one from subtraction. Okay, so we have A equal to 2 minus 4, 3 and 1. And then B equal to 1, 4, minus 2 and 3. So find A plus B, A minus B, and then C, B minus A. So let's find out what values. If I perform this operation, A minus B and B minus A. Will I come up with two different answers, or will I have the same answer? Okay, let's quickly dive into the solution. So we have A plus B. So A is what? 2, right? A11 is 2, B11 is 1. So 2 plus 1. And then we have A12 is what? Minus 4. And B12 is what? 4. So minus 4 plus 4. I have the next one, 3 and minus 2. So 3 plus minus is minus, 3 minus 2. Okay, and then 1 plus 3. 1 plus 3. So this will be equal to 2 plus 1 is 3. Minus 4 plus 4 is 0. 3 minus 2 is 1. And then 1 plus 3 is 4. So that's basically what our answer is. So if I have A plus B, I have to come up with that value as my answer. Okay. So B, I have A minus B. What will A minus B be? So we have 2 minus 1. We have 2 minus 1. What again? Minus 4 minus 4. Right? Minus 4 minus 4. Then we'll have 3 minus 2. 3 minus 2. Please take notes. Minus 2. Thank you. So 1 minus 3. 1 minus 3. So that will be the value. So we put it to the reactor and then we want to find out our results. What will be the result? 2 minus 1 is what? 1. Minus 4 minus 4 gives us what? Minus 8. 3 minus 2. Minus is plus. So 3 plus 2 gives us 5. And then 1 minus 3 gives us what? Minus 2. Okay, so that will be the value. That will be the value. Now let's find out. Will I have the same value for B minus A? B minus A. Okay, so B minus A will be, I'm taking this blue box, so 1 minus 2. 1 minus 2. And then I have 4 minus 4. 4 minus 4. And then I have 3, sorry, no, not 3, B box, right? Minus 2 minus 3. Minus 2 minus 3. And then I have 3 minus 1. 3 minus 1. So 1 minus 2 gives us what? Minus 1. And then 4 minus is plus. So that will give us 8. And then I have minus 2 minus 3 gives us minus 5. And then 3 minus 1 gives us 2. So looking at it, what do you observe? Can you observe something very important? Something very, very important. So you see that this guy is the inverse of this guy. So we have 1 here, here we have minus 1. We have minus 8 here we have 8. We have 5 here we have minus 5. We have minus 2 here we have what? 2. So that's very important thing for you to know about matrices. So I believe this helps. This helps you handle matrix problems very well. See you in the next video where we'll be talking about multiplication of matrices. Alright, do have a blessed day.